Okay, let's have a talk about test equipment. We've had a chat about soldering irons and desoldering tools. If you've watched that video, if you haven't, it's well worth having a look. So now we're going to have a look around the workshop and see what test equipment I have. And we'll talk about what is essential and what is nice to have and what maybe isn't a lot of use really, but we still might have it. So we'll start off with the most basic and the most essential bit of test equipment you can have is a multimeter. You're going to need a multimeter to do any of this sort of work. So that is, if you're on the budget, after you've got a soldering iron, a hot air, multimeter. That is really the next thing you need. I have a few multimeters and other meters here, so I'm going to show you what I have. This is a Fluke 79. I bought this in 1993, so it's now 28 years old. I still use it, and this basically is my weapon of choice. You've probably, if you've seen any of the repair videos, this is the thing I grab almost always. Possibly that's just familiarity. You know, I love this meter. It's been with me a long time, but it's a very useful bit of equipment. It does all the usual things: voltage, AC and DC, frequency, resistance, capacitance, ampage, current. It's got a diode test mode. These are things you'll find on any multimeter. It's an auto ranging multimeter, so I don't have to mess around, you know, trying to find which voltage range. But it does have a button in the middle here, which I can actually specifically set it to a certain voltage range. For instance, on resistance, I can have it auto ranging. I can set it manually. And the reason you might want to do that, sometimes, if you have for example, a voltage that's changing, switching on and off, on and off. If you've got this set to auto ranging, quite often it can't react fast enough. By the time it tries to find the range to use, this thing switches back off again, and it kind of like goes backwards and forwards, and this thing can't keep up with it. So it's quite nice to be able to switch off the auto ranging occasionally. We have a bleeper mode. If I hold this button in, we have various resistance test modes, including the voltage test. That's for testing diodes and resistors. That's ohms range. Just hold it in. Voltage range. This is for testing diodes, transistor junctions. It'll actually tell you the voltage dropped across the junction. Very useful for testing semiconductors. We also have a low resistance range. Thing with this meter, it's well, actually, if I just let's see if I can do this one-handed. If I short the leads together, the lowest resistance this can read is 0.1 ohms. So it can tell you 0, 0.1, 0.2, and so far. So 1/10 of an ohm is effectively the resolution of this meter, which is good enough for many things. But sometimes when you're trying to find a short, it's not really suitable. Another good thing with this multimeter, and any multimeter you buy, it has to be instantly reacting. So when you're basically tracing the circuit, I'm just going to put this here because you can hear the bleep. What you want to do is, as soon as you touch these, you want it to bleep. Because you're probably going around chips on the board and just running along all the legs and trying to find which one connects to somewhere. And if it takes even half a second to react, that's too slow. You'll be past the pin. If you're moving too quickly along the legs, you're moving along the legs quickly, you're going to miss. You know, you were on the one that was connected to the other place, but the meter wouldn't react fast enough. So that's one thing I like about Fluke. I like many things, but in particular, this thing is instant. Instant you touch those together, it reacts. Another quite nice thing, but this is common on multimeters. If you leave it switched on, it switches itself off. After a while, it goes into standby or off. I said I've had this for 28 years, and it's probably had 4 batteries in it in that time. They last almost forever. So that's my Fluke. Just else on meters, you'll see these are the meter probes. When you buy a multimeter, it'll probably come with some rubbishy probes that are not very sharp. and basically they're useless. Buy yourself some of these decent meter probes for every meter you have. It'll save you messing around. You get a good contact every time. You're not like thinking you've got a fault because you didn't have a good contact on your meter. So get yourself some good ones. These had a look, even for almost 30 years old, second hand. These are fetching anywhere 40 to, I think I saw one almost at £90. Okay, it was boxed with the manual, but 40 to £60 for one of these. And it's still my weapon of choice. The second one I have is this. This is the Aneng AN8008. These are about £20, 20, 22, something in that region. This is cheap. It's also an auto ranging multimeter. The two things I like about this, but the reason I bought it, the two things I like, first of all, this has a backlight, so it lights up. This can be very handy in some lighting conditions, especially when you're working out on site. So that's one reason I bought it. The other reason I bought it was this. You remember on the other meter, when I went to the ohms range, the lowest ohms I could read was 0.1. Yeah. This will take me down to a 100th of an ohm. You can see 0.008, yeah? In fact, it's actually 0 to 0 now. 0.0077. So this is 10 times more sensitive than the Fluke. And when you're tracing for short circuits, that matters. So if you were buying one multimeter, I would say get this one, or find something else that's of the same specification. You'll pay, they're cheap, you know, it's like 20 odd quid. It's not, you don't need this thing to be absolutely accurate. It's good enough. This is for fault finding, not for designing circuits where, you know, you care about hundreds or thousands of a volt. So that's the one I would say, if you were going to buy a multimeter now, that one. We'll have a look around for best multimeters online. You know, I mean, this is a few years old now, maybe there's something better. Also with this one, same as the Fluke. When you switch the buzzer mode on this, let's just do that. So, yeah, switch the. It's instant. So, in my opinion, that is a good multimeter. Third one I have is this. Actually, this costs about the same as that Aneng. It's about 22, 25 quid. This is a manual ranging multimeter. And I don't use this very much, but it has a few little features that I like. When I'm trying to look at something with a change in voltage, because this is manually ranging, it's much easier to keep track of what's going on. It reacts a lot quicker. That's really the main reason for having this one. These, funny enough, say there's as much as that Aneng, you think they'd be cheaper because it's an older model, but that's that one, and that's the 3 multimeters I have. I would suggest, actually, if you have the money, buy yourself 2 multimeters. There's many times when you're fault finding that having 2 meters is useful. There's times when you want to see voltage and current at the same time, and the only way to do that was with 2 multimeters. So if you're on a budget, as I said, buy yourself this or the current equivalent of that, and if you've got a bit more money spare, buy 2, or get yourself 1 plus a manual ranging. So that's the multimeters. That's essential. Now, what else do we have, and what do we think about it? This is a capacitance meter. This is for measuring capacitors. It measures everything from like 1 picofarad or something. Yeah, it goes to 200. So it reads from about 1.1 picofarad up to top range on this, yeah, 20,000 microfarads. That's what this is. It's a capacitance meter. Cost me 20 quid. Not much sure why I bought this. I think, you know, sometimes you see these things and you like them. To be honest, both the Fluke and the Aneng have a capacitance range already. And yet, when I want to measure the value of a capacitor, this is the one I grab. And the reason for that is probably not that it's any better at reading capacitors. It's just that by using this, I justify the fact I spent 20 quid on it. Okay. Some of us just cannot resist buying test equipment. Back to multimeters. I said I actually own 3 multimeters. I own 4. This one is an analog multimeter. I bought this again because I thought it was easier with this to see what's going on with voltages that are varying, that are changing around. To be quite honest, it isn't. I wouldn't recommend any particular reason whatsoever why you would buy yourself an analog multimeter. Please, somebody who, if you're watching this video, you can think of some good reasons to why you buy this. Actually, no, there is one reason, and that's what I've used this meter for. I didn't even realise this was the case when I bought it. But when you switch this to the beeper mode, yeah, it's beeping. When this is on beeper mode, it actually sends quite a bit of power down these probes, and these are great actually for testing loudspeakers, because when you get a loudspeaker, let me just see if I can find one. I'll show you this 1 minute. I thought I had a speaker in the workshop, and if I do, I can't find it. But anyway, but the only use I can recommend this for is for testing loudspeakers, and that's about it. So, what else do we have on the bench? This is an Esr meter. This is specifically designed initially for testing capacitors, and it's not a capacitance meter. This measures a property of a capacitor called the equivalence series resistance. That basically tells you how well that capacitor passes AC signals. And when you get power supply circuits in particular that have capacitors, buck regulator circuits, quite often the ESR is very important, and a lot of capacitors fail because the ESR goes high. Typically the capacitance goes low and the ESR goes high, and this will very easily find those duff capacitors. So that's really one good use for this. This is the sort of thing that will save you a lot of time on certain repair jobs. I'm not actually sure. Just out of interest, how much did I pay for this thing? Let me have a quick look online. I know you can't see the screen, but let me have a quick look. MESR 100. £48. I wouldn't call this essential, but it's a very, very nice thing to have. And for certain types of repair, it is so useful. It's bordering on essential, really. This will save you a lot of time, and this will measure this ESR, which there's no other way you can measure it. and you'll very easily identify faulty capacitors. There's another use for this as well. I've tried this. This, as well as measuring the SR, will see an inductor, like a voltage regulator coil, a buck regulator coil, as a resistance. It tries to send an AC signal so it won't pass. And these can be useful as well for tracing short circuits. I've not seen anyone else particularly say that, but I know from a fact that sometimes this will help you, especially if you've got on a motherboard or a graphics card where you've got one of these Gatling gun power supplies with 5 or 6 phases firing in turn, and you know you've got a short circuit, and you don't know, is the short circuit on the power effect side of the coils, or is it on the GPU side of the coils? And the only way you'd normally find that out easily would be to desolder the coils and then have a look to see which side it is, because with a resistance meter you can't tell. The coil effectively reads almost short, you know, there's no resistance in it, so measuring resistance to ground from one side and the other won't really tell you. This will. Let me show you. And when you've seen that, you might think, actually, you know, Rich, that's a rather nice bit of kit to have. Oops, and that we knocked the camera. Okay, so that's the ESR. I have two other meters here. I have two of these. You've probably seen me using these on, if you've been watching the repair videos. If you see the GTX 2080 repair, you'll see me making use of both these together. This is a temperature probe. So this is a probe. You can attach this to a board, and that will give you the temperature. These are great. I mean, these, I'm going to call this essential, honestly. And the reason I'm going to call it essential is because 2 of these is like less than, say, €8, £7 English, $10 or something for 2, you know. So they're so cheap, and yet they're so useful. So because the fact that these are so cheap, there's no excuse not to have them. Therefore, those, we're going to call them essential. We have 2 more. This is it's not exactly a test meter. If I had somewhere to plug it in, but the wire's not very long. One moment, maybe I can do that. Once again, I failed to find a suitable adapter plug, which is a bit of a shame, but can't actually on there. Okay, what this does is, basically, this is actually a backlight tester for LED TVs, and that's what it's for. And I bought this. I was doing some TV repair, and this is fantastic for telling you if any of the LEDs are faulty on an LED TV. But I don't do TV repairs anymore. I don't have space in the workshop to do them. I don't have space to store them while they're waiting for parts. So it's something that I let other people do that. But this actually is rather useful. What it does is it passes with this switch, either 30 milliamps or 1 milliamp between these 2 probes. And when you connect them together, this will be 0. Yeah. If you connect them across an LED, that will tell you 2 volts, whatever the drop is, LEDs. If you've got like 8 LEDs, I mean, great for fixing Christmas lights. You can, if you've got one LED out, you can stick this on one end, and then you can touch all the other ones, and they'll light up in turn until you reach the bad one. So it's great for that. It's great for testing Zener diodes, which are a type of diode that effectively has a certain voltage across it. That's what it's designed to do. If you don't know the voltage of a Zener diode, put this on the 1 milliamp, cross the diode, and this will tell you the voltage. The diode, if it's a 12 volt one, it's an 18 volt one. If it's a high voltage diode, you can go to the higher current. Anyway, that's what that is. It's a nice to have. If you're fixing TVs, yeah, it's essential. But if you're not fixing TVs, it has its uses. But let's see how often you actually see me use that. It's a nice toy. Right, the battery's gone flat in my digital thermometer. I was using this the other day, but basically this is a digital thermometer. I'll put some new batteries in it. This is a very handy little thing. Okay, I've got the temperature probes, but this is quite handy. Just point it at an area circuit board, pull the trigger, and it'll tell you the temperature. It's handy enough to put some batteries in, put it that way. It's a nice to have, but they're not expensive. And this is a fun little device. This is an Atlas DCA55 semiconductor analyzer. This is very nice to have. This will cost you, the Backlight Tester, by the way, price of that was about €50 or €40. I think I'd have to look it up. In fact, why not? Well, let me tell you how much that Backlight Tester actually was. Well, you can get a similar one for like £14, so they're cheap. Do you know, at that price, just for testing Zener diodes and fixing your Christmas lights, I'd have one. Right, this thing then, so the Atlas DCA. This is for testing semiconductors, and the great thing about this is you don't even need to know what the semiconductor is if you've taken some off a circuit board. Okay, if you know what it is, this will test it for you and tell if it's good or bad. If you don't know what it is, this will probably tell you what it is. So let's have a little play with this. The beauty of this is we can take, I don't know what this is, just grab a few bits out of the board, out of the drawer bits, and we can connect these wires to all three legs, and any combination we like, it doesn't matter which one we put where. Yeah, so we connected all three wires to the components, and then we're going to switch this on. And it tells us it's analysing it. The button's stuck in. Okay, yeah, the button's stuck in, that's why it's analysing. So it says that's an unknown or faulty component. Let's have another go. Analysing. Unknown or faulty component. That might be something like a voltage regulator or something that it doesn't know what it is. So yeah, it could be an unknown component. It could be something faulty. If you know what that actually is, and say it's a power transistor, and that says it's unknown or faulty, it's faulty. Let's stick on another one. I think this might be a power transistor. Let's have a look. So again, I'm just putting the wires on the device. It doesn't matter which one goes where. It's a TIC106D. Not sure now. Sensitive or low power thyristor. So it's telling me now that is a thyristor, which is a bit of an unusual component. You don't see them a lot. You'll see them occasionally. We might eventually fix something with thyristors in, and I'll tell you about them. That's what that is. This is fun, isn't it? This is fun. So much fun. You can amuse yourself for hours with this, you know. Stick the components on the end. Again, it doesn't matter which wire I put where. It's analysing, and it says enhancement mode MOSFET. Oh, that's nice. And not only will it tell you what it is, but it will also give us some information about it. I can't see it at the same time. So it's telling me the red, green and blue wires and which pin they're connected to. Gate, drain and source, so that tells us which pin is which. It's telling you the voltage, 3.01 volts at which the FET turned on. Just telling it's using its 2.5 milliamps test current. So that tells us not only about what the device is, it tells us it's working, and it gives us which pin is which. That's handy. I've got three or four more here. Let's carry on. So again, we're going to stick the wires in any order on the device. Okay. Once again, we press the button. Another MOSFET where the button was stuck in. Yeah, it's another MOSFET. Again, it's telling you which wire colour is which pin, gate, drain and source. And again, the threshold voltage, this one's a bit more sensitive, 2.52 volts. So we know that's another a good MOSFET. What else do we have here? Little thing here. Once again, we'll attach all 3 wires to the device. There we go again, 3 wires on it. What's this thing? No component detected. Ah, yeah, because one of the wires fell off, that's why. Let's just stick the wire back on. You fiddly little beggar. Go on. Okay, all 3 wires are on. What do we have? A 3-terminal bi-colour LED. Okay, that was nice. And 1 more to go. So, not only with this can you test 3-pin semiconductors, you can connect 2-pin. Analysing. It's a diode. No. So, oh, and while we've got this diode, analysing the diode, once again we can scroll this one. It tells us the anode and cathode, so you know the polarity of the diode, and it tells us the forward voltage drop 0.66, so that's a standard silicon rectifier diode. So, the DCA55, is it essential? Nah. Is it something that's nice to have? Oh, yes. So, 55 to 60 pounds. There's nothing that was testing that you can't test with a multimeter. But this thing does it much faster, much easier. Come on, you've got to have one of these, haven't you? What do we have here? This is a Logic 16, a USB logic analyzer. Actually, I was given this. I did some work for a company around 2011, some design work for a special interface he was trying to build, and I said to him, I can do the job for you. It was a programming job actually. I can do the job for you, but I need the right kit. So as part of the job they bought me this. It's a logic analyzer. Is this essential? Nah. It's a very nice tool to have if you're into things like Arduino programming and that sort of thing. The only time I've ever used this for repair work was on disco lighting, where I was trying to analyse the protocol it was using to communicate between the two or more disco lights and synchronise them together. That's probably like the only use for this. Can I find more use to it? Yeah, I probably could. I mean, maybe at some point with a motherboard repair, I might actually find a use for this, but at the moment it lives in its little plastic thing. Let's see how much this thing actually is out of interest. It's a Zoyi Logic 16. I'm just interested to see how much this thing actually was. Logic 16. They do a mini version of it for £45, but I know this was a lot more than that. Yeah, I think this one was about 150, but as I say, it sits in its nice little holder, and one day I might find a use for that actually. That'd be interesting, wouldn't it? If we can find some use for this and actually fix some motherboards that we couldn't fix otherwise. That's that one. So that's all the test meters I have. So I want to just now have a quick chat about the other test equipment I have in the workshop. I'm going to move the camera now. Probably knock something over. Okay. Let's see, can we see this? Not all in one go, but we can see enough. This is, I would say, the next most essential bit of equipment you can have after a multimeter. You might think it's a bit of a strange one to offer you, but yeah. Once you've got a multimeter, I think the next most useful thing you can have is a bench power supply, and that's what this is. This is a dual channel one, and I have, one moment, this one. This is a single channel one. So, what do these things do? Apart from causing me to knock things on the floor. With these sort of supplies, I'll show us a look on this one, the single channel. So this is the voltage. So coming out of here on the red and the black is your power. Let's get a couple of leads and attach them to that. Find a couple of leads. Okay. So this is now connected to the power supply. This sets the voltage. So you can see here, this will go down to 0.3 volts. And up to 31.4. So this can provide you any voltage within those ranges. Let's set it to 12. It also has like a fine adjuster here, so you can use that to finely tune, yeah? 12 volts. This is showing you the current. So first useful thing with this is it's very nice if you use this to power up devices, because you can see what current it's drawing, which can be quite handy. But the other thing we have with this is this has a current range as well. This has what's called a constant current mode. So what it means is, basically, if I'll turn it down to start with, it's gone to constant current. I've told it to current can be 0, and this is no, there's more than 0, so it switches it off, yeah? Let's set the current. What I can do is with this now, for example, I can short these two wires together. Straight away, this is now supplying the current that I set. So if I adjust the current here, I can now choose how much current to send into the device. 1.04, so I finally adjust 1 amp, yeah. And that will now basically continue at 1 amp. And the most current this can supply is 5. Yeah. The useful thing about this is very good for finding short circuits. So if you have a device which is short circuit, and you know, for example, it's a 3.3 volt supply rail. So you can set this to 3.3 volts. And you can do that exactly, 3.3 volts. You can decide how much current. And you can send, let's say, 2 amps, yeah? You can send 2 amps into that short circuit. And what will happen is now, hopefully, whichever component is short will start getting warm. because effectively anything that's short is a lot of current going through it. And you can get right up to 5 amps on this, and with 5 amps, if you have a short circuit capacitor or somewhere on the board, all you've got to do is either use your use the thermometer or use the finger. You know, you can just feel around on the board and you can find out what's hot. You can also put a bit of isopropyl alcohol on the board or freezer spray on the board, and that'll very quickly show you what's hot. So these things are great for powering up equipment under test. Say you've got a laptop, you haven't got the right 19 volts power supply, use this. You can see straight away what current it's drawing, which is quite nice, and it's very good for short circuit finding. So that, I would say, after your multimeter, if you're on a budget, once you've bought your multimeter, buy one of these. Okay? If you've got a bit more money spare, buy another multimeter. But that's what I would say. Multimeter and one of these. That's a single power. This one goes up to 30 volts, 5 amps. These will cost you, let me have a quick look, one moment. Let's see what the current price is on these things. Bench power supply 30 volts, okay. Yeah, one like that, there's a few different makes here. £55 for the same one as that one, actually. £56. One basically the same as that, 44. They normally come in 30 volt 5 and 30 volt 10. When I bought this one, I bought the 5 amp thinking that's as much as I ever need. Would I buy the 5 amp one again? Nah. I'd buy the 10 amp. As I've got more into repair motherboards and short circuit finding, I've realised sometimes that you need a bit more than 5. The 10 amp ones, there's not that much difference in price, to be quite honest, of these things. Probably £20 or so. Let's have a look. Well, I've actually found somebody selling a 10 amp version of that for 45. I think I might buy one actually at that price, to be honest. Okay, so that's the bench power supply, that one. I have the other one. So this is the other supply. This is another bench power supply like the other one. The main difference one is this one is a dual supply. So this will give you 2 different voltage supplies simultaneously. It can for instance be like 12 and 12, or we can use this example. I've set this to 5 volts, so we can have 5 plus 12. It has the same current limit as the other one, so you can short it out and set to a maximum current. You can use this with the 2 power supplies in series. That's quite useful if you have something that needs plus and minus 12, for example. It will do that for us. And we can have the 2 power supplies in parallel to double the current. So with the 2 in series, this will give you a maximum of 60 volts at 3 amps, and with the 2 in parallel it will give you a maximum of 30 volts at 6 amps. It also has a separate little 5 volts 3 amp power supply down here, which has overload protection on it at 3 amps. And this actually is the one I probably use the most, more than the other one. There are times when having the 2 power supplies is useful. Mostly I'm only using one, but this does what that does really, and this is the one that I tend to use most of the time. So the multimeter power supply. Next thing I'll just talk to you about is the oscilloscopes. I have 3, 2 of them on this bench. This one is an analog scope. I bought this in 1993, second hand for about £140. All these years later, what's that, 28 years later, I still have it. It's a dual trace oscilloscope, although I normally only use it as a 1 trace. This is a 100 megahertz oscilloscope, so it can show me effectively clock signals up to 100 megahertz. The other one much more recent. This is a Regal Ds1052e. This is a digital storage oscilloscope. This will allow me to capture a waveform and then look at it afterwards. This has a lot of fancy features. It will tell me on here the frequency of a signal, the voltage or millivolts, the size of the signal. It does a lot of maths functions. It's a nice machine. Which one do I use? To be quite honest, this one, the analog one. Most of the time I'm using that for fault finding, because generally speaking, I don't really care what frequency a signal's at or exactly, or what voltage is at exactly. I'm not doing circuit design. I just really want to know, is there a signal there or not? That's the most common situation. And this is just faster. It's less messing around. I don't have to go to the menus. With this I can instantly bump, yeah, I've got a signal. The only time I probably adjust the knob is this one, which is the time delay, and this one, which is the voltage range, and that's it. So yeah, for a repair point of view, that's the one I use. There are times when I need this one. That cost me, I think it was somewhere, I mean, again, I'm not quite sure. I've had that for a few years. Let me see. This one's actually superseded now, and I'll tell you what there is. DS1052. Yeah, about £280. Yeah, that's what they're about, £280, £300. So that was the cost of this. This cost me about £130. This is a 50 megahertz scope, but it can be easily hacked. I think it's just a USB. Even you just load a different firmware and make it into a 100. Have I done? No, I don't really need to. I've got a 100 megahertz scope here. But recently I've been thinking that actually might be useful when I'm looking at motherboards at clock signals. I've never looked into this before, but sometimes I can see a motherboard where there isn't anything particularly wrong that I can see. Everything seems to be right, but it doesn't work. And it's possible, but this is only supposition, I don't really know. It's possible that you might have a case where if a clock frequency is at the wrong, like a clock generator is generating the wrong frequency signal, it might cause a problem. And I'm interested to have a look to see on faulty boards if that is ever actually the case. So I might actually put the hack into this and set it to 100 megahertz, because this will actually show me the frequency on the screen, where this one I have to effectively look at, is it like 0.8 of a division, and calculate by the time, the milliseconds or microseconds, and effectively do a little bit of maths to work out what the frequency of something is. So, oscilloscopes, essential or not? No. They're not essential. You can do, I would probably suggest, 80% or so, maybe even more, of repair jobs without that. Just with the multimeter and the bench power supply will probably get you somewhere around that 80% area. But the other 20%, when you have the scope, it will probably allow you to not you can't fix everything, so you won't get all the 20%, but that will give you a good chunk more, you know. And if you start doing this quite a bit, and you're buying stuff and you're fixing and you're selling, you're making money, I would say put some of your money back into some equipment. Either buy yourself a second-hand analog scope or a digital. I believe now for the same price as this, you can get a 4-channel one or 200 megahertz. I'm sure you can get a better scope now for that money. But yeah, that's that. So what else do we have here? This is a Variac. Basically, this has mains voltage coming in, and coming out I can alter. I don't know if you can actually see this on the Frankenstein laboratory scales here, but with this I can adjust the mains voltage from 0 to 260. I can actually go to 10% above and down to 0. This is quite handy if you're working on power supplies, switch mode power supplies. which can be quite dangerous to work on, to be quite honest. There's some very high voltage in there. But most switch mode power supplies, ATX power supplies, that sort of thing, can work these days on a wide range of voltage from about 80 or 90 volts up to about 260. And it can be quite nice sometimes to use this and drop the mains voltage down to a safer level. Essential? Nah. Nice to have, oh yes. That's the Variac. I'll just mention, this Variac isn't connected directly to the mains. It's connected to what's called an isolation transformer. And the isolation transformer effectively isolates me from earth, from ground. And that makes it much safer to work on high voltage equipment like ATX power supplies and switch modes. We'll talk more about that when we look at some of them for repair. It also allows me to use the oscilloscope on that type of repair in situations where I wouldn't be able to. So the isolation transformer is actually, in my opinion, more important than that. Is it essential? That's a difficult one, you know. If you never work on things like ATX power supplies and non-isolated mains equipment, some vintage electronics is like that, switch mode power supplies, if you never work on those, you don't need it. It's not going to give you any advantage. If you do work on those, not only is it essential, that thing can save your life. That isolation transformer can save your life. What can be more essential than that, yeah? They're a bit hard to get second hand, £50 to £100, but for certain sorts of work, you've got to have it. You really got to have it. You'd rather be alive, yeah? Okay, so that's that. Last little thing I have here, up here, sitting on top of it. This is a function generator, and it's a frequency counter. It will generate square waves, pulses, triangular waves, sine waves, frequencies from less than 1 hertz up to, I think it's 10 megahertz as a maximum. And as a frequency counter, it can measure frequencies up to 60 megahertz. I bought that when I was doing some audio amplifier repair work, and I wanted to effectively stress test amplifiers, but shortly afterwards I stopped doing that sort of work. I used it once repairing disco laser, a high-end one, which had some fault driving the mirrors, and I used this to inject sine waves into the circuit so I could trace the circuit and find out at which point it was distorting, it wasn't working. So yeah, it had its uses, but it's not. It's nowhere near essential. You can get one of them. I looked up it earlier today. I think about £30. They're not expensive, you know. But the thing I've never used on that is a frequency counter. This 60 megahertz. It occurs to me, rather than using this to measure clock frequencies, I can probably use that. So when we do some repair work, or maybe look at some working boards, let's have a look around on that frequency counter and see if it'll tell us exact frequency that clocks are working on. That can be quite useful, and it may also mean actually that sometimes we can do away without the scope by using that £30 bit of kit in a lot of situations where you would need to use an oscilloscope. So yeah, the jury's out on that one. Is it nice to have an essential? Let's just leave the jury out on that one, and we'll find out. Okay. So I think that's all the test equipment I have. Portable TV, dead useful for certain types of repair jobs. Swing around. Magnification. A lot of this stuff is really miniature. I don't care how good your eyes are. Some of it is going to be so small you can't work on it. Not with a naked eye. I have two forms of magnifier on my bench. This one, which is a bench magnifier. You can see it's like a cantilever thing. And I can bring this over the bench, and I can work. I can work and solder on this, and I can look through this and have maybe 10 or 12 inches of space to work underneath. In fact, let's just move the camera down a little bit. Let's have a look. So, Workbench Magnifier. So I'm normally working like this at this sort of height, and you can see I have a lot of room to work there. That's bordering on essential. I'd say, look, you get this for like £25 or £30 again. They're not expensive. Get yourself one of them. At the very least, very least, if you don't get one of those, at the very least, you've got to start with something, yeah? So you've bought your multimeter, you've bought your soldering iron, your hot air, you've got yourself a bench power supply, and you're short of money. Jeweler's loop. This is very good. I've actually soldered, before I had a proper microscope, and stuff that this wasn't powerful enough, I've actually soldered. I've actually used this, looking through the loop. You have to get things very close, this sort of height, but I've actually used this to solder. I've certainly used this to examine soldered work, micro soldering, to see, you know, I've got any short circuits. A few pounds, you know. I sometimes use this even now if I've got a board at an odd angle where I can't get the microscope easily to the board. Yeah, that lives on top of here. That gets used. Magnifiers. I'll just mention this, by the way. This is the bench cam, desk cam. You've seen this on the videos now. This is desk cam. And this is how I'm actually doing the latest video, where I'm actually zooming the camera in and out, yeah? You'll see these on eBay and places, and it will say it's 5 times magnification. And you'll also see the one say the 5 diopter. And some of them you'll see is 8. The most common ones are 5 and 8. And often these sellers, usually Chinese sellers for some reason, say 5 times magnification, 8 times. It isn't. The 5 and 8 is a diopter. And diopter is not magnification. Basically, the formula is diopter divided by 4 plus 1. That's the magnification. So 5 diopter, 5 divided by 4 is 1.25, plus 1 is 2.25. That's the magnification. Likewise, if you have a 8 diopter magnifier, it's not an 8 times magnification. It's 8 divided by 4 is 2, plus 1 is 3 times. My opinion, the best one is the 5. It causes less distortion to the image near the edges. But you know, if you get a chance to try them both, try. But I use that one, which gives me, as I say, 5 divided by 1.25 plus 1, 2.25, and that's good enough for most I'm working on. So that brings us to microscopes then. After that, I actually, this is my microscope. This is what I use now. This is a trinocular microscope. It has the illuminated light there on the work. It's a trinocular, so it has the camera. This is the microscope cam. You'll see it on the videos. And this is what's called a double boom stand. Yeah. This is what I have now. But before this, I had a USB microscope. And you'll see a lot of these USB microscopes on eBay and places like that. And the one I had was this Aneng Star A8302, something like that. Let's have a look. Aneng Star 302. Aneng Star ADSM 302. And they're quite considered to be quite a decent microscope. You'll find a lot of people say for the USB microscopes that is a good one. They cost about £180. I mean, they're not a cheap device. Are they any good? Well, I had one, and you can just have a little built-in screen, or you can 5-inch, I think, or you can connect it to a TV monitor. and it magnifies, it's clear. There's HDMI, there's no delay, and it's very good for examining boards, like we look at the graphics cards and things where we want to have a look around. The only disadvantage is that the base. So the base is like so wide, you have the arm with the mouse scope, and with an like an ATX motherboard, there's not enough room. You can't get the whole board. You can look around the edges, but you can't look at the middle. So that's the first disadvantage. But as an inspection microscope, yeah, it's pretty good until you come to try and solder under it. The problem this is for me. I mean, you'd have to try this. What I suggest you do, if you're considering one of those USB microscopes, the first thing to do is get an eye patch, okay, and try and solder with one eye, okay, and do that for 30 minutes. If you can solder with one eye and you have no problem with the fact that you've lost all your depth perception, then you're going to be fine with that microscope. If you, the same as me, find that you just cannot solder with one eye, then it's useless. It's going to be no good at all. So don't waste your 200 quid and buy one of these high-end USB microscopes, and certainly don't waste 30 quid and buy a cheap one, because it's not, apart from inspection, it's just no good. That's why I now have this. You don't need one with all the features I have. I've wanted to do a YouTube channel for a long time, so that's why I wanted the one with the HD camera, everything on this. I'm working on big boards, so I want one with a lot of space. So you can see back here, this is the stand, and there's a lot of space between there and the bench. There's a lot of room to work under here. This has two different lenses I can fit on it, interchangeable. This will give me, on the weakest of the two lenses, 3.5 times to 45 times. On the stronger the lens, it will give me 7 times to 70. Was it 90? Yeah, 3.5 to 45, 7 to 90. Do I need the 90? Nah. I've never ever put the other lens on this. Even with 3.5 times magnification, it's more than enough. Occasionally I'll zoom in. It's a zoom microscope. I can zoom in. You've seen this on the screen on some repair jobs. Actually, when I'm looking through the eyepiece of this, I see much clearer these on the screen. First of all, I've got stereo vision, okay? And secondly, I have a wider field of view than that camera has. But any microscope can give you 3.5 times is enough. You know. But that's how they come. Zoom microscopes, they normally go. So the 3.5 to 45 is great. The main thing that's made this expensive is the double boom stands. The advantages to that. But you can buy microscopes, AliExpress in particular, maybe on eBay, which will give you the same magnification as that. You probably don't need a camera. Although actually, even if you're not making videos, a camera's very nice to have, because quite often, if you want to examine the board, it's a lot easier to just look at it on the screen. You don't need the stereo vision. But you can buy cameras with that. You can buy microscopes with the same sort of features for maybe £150 or something to 200. Certainly around the same price as that Aneng Star. You can buy something, and that's where you should be spending your money, not on the other one. Really, trust me. I've had both. You okay? What else do we have? Anything else around the workshop? We have tools. We'll do a separate video on tools. We have one other thing I want to talk about, and then I think we've seen everything. And that is, you've seen this on all the videos and everything else, the mat. This is an anti-static mat. It costs a few quid. I mean, they're not cheap. It's earthed, and the earth is connected. It's not to the voltage of the power supply. There's an earth pin in the middle, which is grounded. So this is connected to ground. You should wear a wrist strap and a curly wire to here. You'll notice I don't wear the wrist strap. In all the years I've been doing electronics, I've found that if you're working on a mat like this, and this is grounded, I can touch this anytime. I'm really discharging any static electricity in myself, and it's the static electricity that damages chips. Do you need an anti-static mat? Yeah, really. I mean, there's no excuse not to use it. Not only does it protect things from static discharge and components, it's a nice surface to work on. It's durable, it's hard, but it's slightly spongy. Yeah. You've got no excuse, I'm telling you. Get yourself an anti-static mat. Oh, there's a couple of things. I don't know if you've seen on top of here what looks like, and actually is a light bulb. I have two of these. These are homemade. This is the other one. So this is a remarkably handy bit of kit. Coming in here is your mains. Okay, we have two light bulbs and a power socket going out, and then we have a switch. And the switch says limit and live. Yeah, limit, live. This is one of the most useful bits of kit you can have in your workshop. I'd put this under essential. Okay, so after you've got your multimeter, your soldering iron, your hot air, your bench power supply, make yourself one of these, or even before. Let me show you what this does. Let's see. I'll draw you a diagram so I explain to you what this is, and this will also be very good if you want to make one of these. So, what do we have? We have mains coming in, yeah? Live and neutral. The live goes to a light bulb. That's a light bulb, yeah? And coming out, live, neutral. So this is your mains coming in, this is your mains going out, and then between is the light bulb, yeah? Let's draw more. Mine has two light bulbs. So what I have is connecting across here. Another light bulb. And I could put a switch here, but I mean, I can just unscrew the light bulb, yeah? These are not LED. This will not work with LED. These need to be halogen lamps or proper filament lamps. It's a halogen, it's a filament. This one is 60 watt. And this one is 100 watt. And then, connecting again from here, and from here, across both, is a switch. Limit and live. The switch, yeah? The switch. That's the switch. When the switch is open, the power, when the switch is open, the power coming in goes through the light bulbs and out, yeah? When you close the switch, it just goes straight through. Now, let's say we connect this to something under test. Power supply. PSU. And let's say this power supply has got a short circuit. If you plug this into the mains, something's going to go bang. You plug this into the mains and switch on, and that's probably a new pair of trousers. A new pair of trousers, yeah? Because you just crapped yourself. Right. Now, imagine we're using our circuit. So you've now got two light bulbs. Yeah? We connect something here short circuit. What happens when we connect something here short circuit? We plug it in. Does it go bang? No. The light bulbs light up. That's all that happens, is the light bulbs light up. So any unknown device I have under test gets connected to this first. The reason I have 2 light bulbs, by the way, is because normally I would start with just this one unscrewed, so it's just a 60 watt. If that 60 watt lights up, I know full well I have a short here. If it lights up and then goes dim, or if it lights up, say, to half brightness, I know I don't have a short, but it's not supplying enough power into this. So then I would screw in the 100 watts, and I'd give it 150 watts. They'll either light up a flash and go dim or off, and this thing will come on. That means it's good. Or if they light up again like a half brightness or a quarter brightness, this just needs a lot more power. Now, I'm confident if I close this switch, it's not going to go bang. So that is a current limiter. Something you can build yourself. Cheaper than a pair of trousers. Okay. So, there you go. Build yourself one of them. Also, when you do have a short in here, because of this thing in the light, some of the power... If you do plug something that's here is short and these are lit up, there's still some voltage going into here. It's flowing through here. And quite often you can trace the fault in here safely without it blowing up. The same applies that if something's gone bang previously and you replace components, you spent £15, £20 repairing this, what's going to happen when you plug it in? If you didn't find all the faults, it's going to go bang again. Right, this will stop it happening. This will save the components that you bought, and that's cheaper than the 20 quid, plus the pair of trousers. So, that's what's in the workshop, guys. That's all the things. We'll have one more tools, I think, just to give you an idea what you might want in tools. To end all that, what do you need? Essential. T12 soldering iron. Cheap hot air station. If you can get one, a preheater, air preheater. Digital multimeter, that Aneng 8008 or something similar to that, great. And the bench power supply. That'll get you 80% of the way there. After that, the next most nice things to have are the oscilloscope. We'll put this in the essentials, so that as well. Oscilloscope's nice to have after that. And if you were intending to repair power supplies, ATX power supplies and equipment that's directly connected to the mains like that, save your life, get an isolation transformer. Okay guys, hope you enjoyed that, and I'll see you on some more videos. Ah, one addition, you see, I was going to see you in the next video. No, listen, I'll just show you the last bit of this bench. Behind the microscope we have monitor. Yeah, this monitor has HDMI input, DVI input, VGA input. If you're repairing computers, you need one. So I keep it fixed onto the wall, it's out of the way. Monitor. Down here, this is my computer. This is on the internet. This is where I'm going to be browsing for circuit diagrams, custom component data sheets and such like. So that's that. Quick look down here. Mixer, very useful for audio work. Vacuum pickup tool, which I've never used, although I bought it. And that's basically what's in my workshop. Behind me, why not? These are like little plastic, like cardboard boxes, yeah? Keep yourself organised. When you're working on this stuff, when you've got something in bits, because you need to get some spare parts, yeah? So you put it on one side. Do that. Each one of those post-it notes will tell you what's in that box, what parts it's waiting for, yeah? And what you know about it. In there you can keep the thing in bits, you know, your components in a little bag and whatever. So get yourself organised. If you don't, I know what's going to happen. You're going to, by the time the bits arrive, you can't remember what you wanted them for. Okay. If you do remember what you wanted them for, you now can't find the screws that belong to the laptop or the motherboard or the heat sinks that came off the North Bridge and whatever. If you do it this way, and you can keep a note in there, so you make a note of what you've done, where you've got to. When you pick that thing up in 2 weeks' time or 3 weeks, whenever the parts come next week, although you think you're going to remember, if you've been looking at all the stuff in between, you're not going to remember. That's like 6 jobs ago. So get yourself organised like that. These come from IKEA, but I'm sure you can get them from any stationery shop. So get yourself organised, and it'll make life much easier for yourself. Okay, really, that one is it, guys. See you there.